With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, our question is how much of the alpha anomer and beta anomer are present in an equilibrium mixture with a specific rotation of positive 52.6 degree. So here's the solution. In the question they have asked about the alpha anomer and beta anomer. So first we will draw the structure of alpha anomer and beta anomer. So first we will draw the structure of alpha D-glucose. This is the cyclic structure of alpha D-glucose. There is an H group, there is an OH group, this is the anomeric carbon, and there is an CH2OH group, there is an H, there is an H, and there is an OH. Here at this position we have OH, and there is H, and there is an H, and there is an OH. So this is the structure of alpha D-glucose. And it have a specific rotation of positive 112 degree. Now we will draw the structure of beta D-glucose. This is the cyclic structure of beta D-glucose. Here in this beta D-glucose, the hydroxyl group present at anomeric carbon is cis to the CH2OH group. So this is the CH2OH group, and this OH and this CH2 group are at cis position to each other. So there is an H, there is an HOH, there is an OH, there is a H, and there is a HOH. This is our beta D-glucose. And it have a specific rotation of plus 19 degree. So here in alpha D-glucose, the hydroxyl group present at anomeric carbon is trans to the CH2OH group, and in beta D-glucose, the hydroxyl group present at the anomeric carbon is cis to the CH2OH group. Now here in the question it is given that the alpha anomer and beta anomer are present in an equilibrium mixture with a specific rotation of plus 52.6. But here we know that the alpha D-glucose have a specific rotation of 112 degree and the beta D-glucose have a specific rotation of 19.2 degree. From here we can say that when these two are in equilibrium, the alpha D-glucose changes its specific rotation from 112 to 52.6 degree, and the beta D-glucose change its specific rotation from plus 19 to plus 52.6. This is the specific rotation at equilibrium position. And this phenomena of spontaneous change in specific rotation of an optical active compound with time to an equilibrium value is known as the mutarotation. Thus from here we can say that when a plane polarized light is passed through a solution containing alpha D-glucose and beta D-glucose, then the alpha D-glucose and the beta D-glucose are interconvertible. Therefore we can say that they both are interconvertible. Interconvertible means the alpha D-glucose will changes to beta D-glucose and the beta D-glucose will changes to alpha D-glucose. And due to the interconvertibility of both the anomers, there is a change in specific rotation, and which will be 52.6 at equilibrium. At equilibrium, we have alpha D-glucose and beta D-glucose in solution. This is equilibrium, and we have alpha D-glucose and beta D-glucose. Here both the form of the glucose are stable because they both are cyclic, and cyclic form are more stable than the open chain structure because in cyclic form the molecule arrange themselves in a space to minimize the steric strain. So in cyclic structure there is a less strain, and in alpha and beta the beta position is more stable than the alpha position because the hydroxyl group present at the anomeric carbon is at equatorial position. Thus the steric hindrance is less, therefore it have less steric strain. Whereas in alpha D-glucose, the hydroxyl group present at the anomeric carbon is at axial position. Therefore it experience some strain. Thus from here we can say that the equilibrium solution contains 64% of the beta D-glucose and 36% of alpha D-glucose. So these are the compositions of alpha D-glucose and beta D-glucose in the equilibrium solution. So here this is our answer. Thank you.
For class 6 to 12, IIT JEE and NEET level, Trusted by more than 5 crore students. Download Doubtnut app today.